Hi friends, welcome to the NPTEL course Strategy and Technology, a practical primer. We are in week 6 with the theme of structural analysis and competitive strategy. In this week, which is the 27th in the series, we discuss structural analysis once again, but in a different light. New technologies, including digital technologies, are reshaping industries in 4 ways: reinforcement, reconfiguration, transformation, and reinvention. These are the 4 different ways of looking at industry structure, which will be talked about in this lecture. Reinforcement makes existing products better through digital technologies. Digital and new technologies, when they create an entirely new domain of applications, it becomes transformation. When digital and brick and mortar businesses complement each other, it is industrial reconfiguration. Reinvention is the next horizon of development of fundamentally new technologies, including but not limited to various new technologies such as artificial intelligence, machine learning, robotics, renewables, genetics, and so on. Each of these industry changes has a different impact on each of the 5 industry level competitive forces that are a part of the theory of competitive structure and strategy. While we define business as a multi-industry concept, a stronger foundation would emerge when we understand the dynamic concept of industry in terms of the evolutions which I highlighted just now. The structural analysis framework, as we all know, and the generic competitive strategy framework, as we have just discussed, are based on Michael Porter's books on competitive strategy and competitive advantage. And the background for this in terms of the forces within an industry and how they impact the industry have been discussed by me in an earlier lecture. I also have discussed how generic competitive strategies provide the philosophical labeling and inspiration for companies to move on a particular trajectory. I also discussed how economic forces act as supplemental and overriding force structure on the industrial level forces. Now in this lecture we'll talk about the foundational plank of strategy that is getting impacted by various structural changes that are very relevant for the industry 4.0. There is a working definition of an industry which is very easy to appreciate. It is a group of firms making products that are close substitutes of each other. Computer industry comprises mobile phone, tablet, laptop, all-in-one desktop. We are calling all of these things as part of computing industry because they are somewhat close substitutes of each other. Once upon a time, a phone was never a close substitute of a computer. However, with the kind of advancements that have taken place in terms of convergence of many functionalities in a mobile phone, we have computer industry covering mobile phones as well. A mobile phone does everything what a computer can do today. Therefore, defining the relevant industry is a crucial first step in competitive strategy formulation, which also we have considered in the past lectures. We also have considered that the proper definition of the industry or industries has become an endlessly debated subject as well. Structural analysis can focus broadly on competition well beyond these existing levels, and that should reduce the need for debates where to draw the industry boundaries. Again, the concept of close substitutes is liable for varied interpretation. In the above example of the computer industry, while the products may have similar technical architecture and user functionalities, they may not be close substitutes either. Typically, a company, be it Apple, HP, Microsoft, or Dell, does make 2 or more of the 4 products listed, but not necessarily all of these things together. For example, Microsoft doesn't make mobile phones until recently, but the evolution of the industry and the integration of the adjacencies in the mainstream industry enable companies to take strides towards broader definition of industry and acceptance of several other products within the industry ambit. There are 3 aspects of the industry triad. One is the customer need, second is the product, third is the process. These three together constitute the backbone of the industry. These also define discrete industries and businesses. Industry segments in the automobile industry are two-wheelers, three-wheelers, car and SUV, commercial vehicles. What is broadly termed as the automobile industry is segmented in terms of the product configurations and also the user needs. Another way to look at it is the process of manufacture of these products. A two-wheeler manufacturing facility cannot make a passenger car, and a passenger car manufacturing facility cannot easily make a truck. A truck manufacturing facility cannot easily make two-wheelers. Therefore, there is a definition of the industry based on the customer need, the product and the process. There are common factors as well as different views. Within an industry comprising multiple product lines, industry definition can be approached from multiple angles. We can look for product commonality across three groups of products such as scooters, motorcycles and three-wheelers. They all look after micro personal transportation. We can look at passenger cars and utility vehicles, which look at family passenger transportation as well as individual transportation. Utility vehicles and light commercial vehicles can be seen together as offering certain benefits for small businesses. Light, medium and heavy commercial vehicles can be seen in terms of cargo logistics or in respect of passenger transportation. There could be commonality based on buyers. Scooters, motorcycles, passenger cars, utility vehicles, they are all bought by people who are interested in personal transportation. Cargo, three-wheelers, light commercial vehicles are bought by certain segments of customers who are interested in light cargo transportation. Light buses as well as medium buses are bought by schools, colleges and transport undertakings. Light, medium and heavy commercial vehicle trucks are bought by fleet owners, people who are engaged in intercity as well as state and national transportation. So there is a buyer commonality defining different groupings of products. In terms of manufacturing, scooters, motorcycles and three-wheelers can be manufactured by a common facility. Passenger cars and utility vehicles can be manufactured by a common facility. Utility vehicles and light vehicles can be manufactured by one common facility. Medium and heavy commercial vehicle trucks can be manufactured by a different type of common facility. We cannot do one in the other easily. You can also look at this from a mobility point of view. There are products of individual transportation such as the two-wheelers. There are products of family transportation such as the passenger cars and utility vehicles. There are products of public transportation such as the light commercial vehicles and medium commercial vehicles in the bus form. And there are vehicles of freight transportation such as LCV trucks and MHCV trucks. It is evident from the above that even within an industry, there would be considerable latitude for individual firms to choose different ways of defining their target industries or target businesses. And how they define those industries and those businesses determines the competitive strategy. The right priority. In the contemporary world of fast-changing technology, conventional views of industry and business are getting rewritten. In fact, disruptive developments may start from new creative definitions of industry and business. In future, industry definition may have little to do with the choice of strategy. That is, irrespective of the type of industry, the strategy could be completely common or completely different, because it is the technology that needs to be considered while defining strategy. Porter wisely held that industry definition is not the same as defining the business in which the firm would like to operate or compete. That is, defining its business. So on one hand we have industry definition, on the other hand we have business definitions. Decoupling industry definition and defining a firm's business will go a long way in eliminating needless confusion in drawing industry boundaries. So we have customers who act as buyers and who have needs. This is supported by the changing perceptions of the buyer groups as to what they really want. Customers are not really consumers. Customers are also not people who will buy. A specific set of customers who are willing to put money to take a product or service are the buyers. And those buyers, usually the 99% of those buyers are also consumers, that is, who fulfill their needs with the products and services they bought. From owning a vehicle for personal transportation to leasing a vehicle for the same purpose, and finally just for mobility, there could be a world of fast changing technological needs and customer need fulfillments. What is the paradox in the industry? From a national perspective, irrespective of firm level business definition, industry would remain the operating concept, and that would be influencing a nation's policy environment as well as a firm's competitive strategy. Reverting to the linkage between economy and strategy, which we covered in the earlier lessons, definition of industry remains important. Structural analysis is rooted in the industry, but the definition of the industry is not rooted in the methodology, as we have seen. There are several ways of defining an industry, from product commonality, buyer commonality, manufacturing commonality, and even purpose commonality. By providing considerable freedom for firms to draw boundaries, firms which view themselves as part of an industry are in fact more realistically parts of different industries. This drawing of the line or the boundary between the end product industry and the supplier industry remains a key aspect of structural analysis. For example, semiconductor or chip is not a vendor input. It is a crucial industry by itself, given the enormous amount of electronics in all products, from cars to phones. So we cannot call, in today's circumstances, semiconductor industry as just a vendor industry. It is beyond an industry. It is a industry that straddles the existence and growth of several industries, from cars to phones. Therefore, structural analysis of the industry has to encompass not only the core industry but also many supportive industries, going as much forward as even satellite telecommunications and global positioning as well as navigation. Strategy formulation must therefore be based on this kind of expansive structural analysis, not necessarily on one industry but on multiple industry and market segments. Chronic problems of a supporting industry cannot be wished away as the problems of some other industry. They are all interlinked. That is the paradox in industry definition. We also have the paradox which gets sharper when you look at the fast changing developments in technology and business that are constantly redrawing product profiles, specifications, and usage factors. Earlier, we had different methods of communication: voice, data, print, and visual. And each of these used to power different kinds of products and services. Rather, different kinds of products and services were providing for us those functionalities. But today, convergent products are providing divergent services. Services which were discrete are being provided by one single product. Industry segments and market segments therefore appear to follow no pattern. There is no gainsaying that the era of convergence has reached its limits. Phone plus camera plus AV streaming plus navigation plus health tracking plus personal assistant could be the evolution of a smart device of the future. And are they the products? Are they the service providers? The distinction between a product and the service has blurred. The symbiosis between a product and its applications has increased enormously. Therefore, a smart device maker can no longer assume that continued convergence and deepening of various components will automatically ensure competitive superiority. We need a different set of functionalities to be defined in a creative way to keep this growth momentum moving. The other industries which got converged will also be similarly formulating strategies to retrieve the situation. That is, AV streaming would be wondering how to improve the AV streaming from getting confined to one medium, but rather compete on a larger plane with the ultimate theater experience, so to say. So the other industries have to look at ways in which they can come on to their own, integrating the industries with which they were trying to be a part of until recently. So it's a matter of divergence of the converged industries. It would also be reconvergence of those divergent industries. This process of convergence divergence will keep on going forward even as newer technologies are developed and artificial intelligence and other capabilities provide a new edge to the way the products are designed and developed. In-depth experience has to be obtained from divergent devices. Ultimately, no one can really provide the same level of AV streaming quality as a television provides, and television cannot provide the same AV streaming quality as a theater would provide. So divergent devices continue to have their relevance, but each device will try to see how they can integrate these divergences and provide superior convergence as well as superior convenience for the users. So the structural analysis framework has to be redrawn given this kind of fluidity in the structural parameters, given the fluidity in the definition of industry in the current era. So decades of profound technological change, which have now accelerated to exponential change, are going to redraw how industries will function, will perform in future. And there is this industrial digitization which is driving every industrial development. Over the past 3 decades, every industry had been reshaped by electronics and software as a broad stream of digital technologies. And these are exemplified by computing, communication, navigation, and sensing technologies, among others. This intensity and scope of this reshaping is occurring in 4 ways. First one, probably the basic one, is reinforcement. Reinforced industries are the ones that retain their basic technological characteristics and usage requirements, but have deployed digital technologies to redefine the levels of sophistication. Reconfiguration is the second way the reshaping is occurred. Reconfigured industries are those that have emerged from new or extended business models through aggregation and digital buyer-seller exchanges. Both aggregation and disintermediation are a part of the new digital wave that is reconfiguring various industries. Transformed industries are those industries which are threatened almost to extinction by digital technologies, but have altered themselves through integration of digital technologies. And reinvented industries are those which are completely recreated based on fundamental technology and fundamental science from zero base, and they fulfill obviously some basic requirements, but they have been discovered out of their latency. A few examples in each case will demonstrate the complexity of structural analysis and industry definition in this emerging scenario. Let's look at reinforcement, that is creating a digital marketplace or a digital support system for a physical company. Most basic and core industries have already been substantially reinforced by the integration of electronics and information technology. Ashok Leyland, a manufacturer of commercial vehicles, is a pioneering example of a physical firm creating a digital marketplace. AL's digital marketplace comprises iAlert, Service Mandi, eDiagnostics, and Laycart. iAlert is a telematics solution for helping the drivers find their optimum operating conditions. Service Mandi is a digital service system by which a truck operator or a bus operator can access service from any part of the country. Laycart is a mobile application which offers round-the-clock availability of Ashok Leyland spare parts. And eDiagnostics is visual consultation to troubleshoot the trucks and come out with on-the-go service and downtime minimization. These digital solutions enhance customer efficiency, performance, and profitability through various means of anytime, anywhere support for the vehicles. This will also ensure that the customer enjoys the highest uptime with our vehicles, and these solutions are unparalleled in the industry according to Ashok Leyland. This is a physical company getting reinforced with digital support. So let's delve deeper into the iAlert Telematics Solution. The iAlert Telematics Solution is a great example of digital reinforcement. What does it do? It does vehicle tracking, trip management, fuel management suite, fleet insights, geofencing, driver management, fleet management, proactive vehicle service support, alerts and notifications. As a result of this, what happens is that the driver is always in real-time connectivity with the central server which provides the telematics support, and the operating conditions are continuously monitored, and alerts and notifications are provided in terms of either the right kind of gears to be used, the right kinds of speeds that are to be deployed. And this has been going from one generation to another generation, and iAlert 3.0 is now available with rich user interface, two-click navigation, and various web features that are supported in the mobile application. And this also therefore is coming up with upgradation of truck operators into more smart devices as part of this telematic ecosystem. It is definitely a value builder for the drivers and fleet operators, and also it provides almost limitless data on vehicle operating conditions and performance that will enable the company build better vehicles. It is also a precursor to a homegrown connected vehicle solution. Digital technology thus reinforces the physical platform. The GE CEO Jeff Immelt told the world that trillions of data is getting available from their aircraft engines, GE's aircraft engines, and that data must be analyzed and newer and better engines must be developed, he averred. And the same philosophy applies even for trucks or any other product which is generating data on performance. This is the reinforcement of existing industries, the physical industries, by digital solutions. Let us look at reconfiguration. Several industries in the consumer sector, on the other hand, were initially threatened by the emergence of digital technologies that promised to provide completely new ways to design, manufacture, and deliver products, as well as provide services to consumers. However, it has emerged that digital is nothing but a new way of reconfiguring the traditional industries and businesses. Internet has changed the way producers and consumers are connected. Electronic retailing has made brick and mortar retailing feel highly threatened. Digital imaging made film photography obsolete. Electronic books offered a new channel, procurement and reading, closing physical bookstores. Eventually, however, conversion of digital threats into business supplements enabled several industries to recover and transform themselves. Food delivery has come in, but kitchens haven't gone out of fashion. Cloud kitchens may have come, but kitchen as the central source of food delivery hasn't gone. In fact, it has become more sharp. Retail, publishing, imaging, measuring, diagnostic, media, entertainment, ride handling, co-working, delivery and hospitality businesses, to quote a few, have therefore reconfigured themselves to have digitally reconfigured physical businesses. Zomato, Swiggy, Dunzo are all great examples of digitally driven food delivery, and this has created a multi-billion-dollar industry globally. But how are they seeing their industry today? Food delivery companies are no longer looking at themselves as food delivery companies. They are looking at delivery companies. What will prevent then a courier company such as Professional Couriers or DTC to enter the food delivery business and say that my business is also food delivery? They might start with intercity food delivery, as Delivery has done, as Porter has done, and come into even intracity food delivery. Therefore, the industry lines are getting blurred, and companies are having much greater openness to redefine their industry boundaries. Whether this will lead to everyone fighting with everybody else, or it will lead to some kind of industry shakeout to ensure more proper and more specialized industry boundaries, is a matter for the future, and that future is not too far away though. Strategic collaboration and operational synergy between physical providers, that is the restaurants and kitchens, and the food delivery companies is vital to ensure the success of the digital reconfiguration model. The demand for food, assuming that the COVID-19 related pandemic didn't exist, is probably in fact in the new situation of food delivery companies coming in to supplement in restaurant dining. That is the power of reconfiguration. Similarly, the FMCG companies are experiencing that having their own digital stores is adding to their sales, even in these times of COVID-19 when in-stores visits are limited. This reconfiguration is taking a new hue also. It is not always offline to online. Online to offline is also occurring. There is a realization that reconfiguration is not an end, and both the physical and digital industries need each other for synergy. They need to serve the customer more effectively, and in this process, they need to upscale and synergize each other. From a collaborative arm's length approach, the current trend indicates selective merger of the physical and online. Amazon has acquired the physical marketplace of Whole Foods. Byju's, the online learning app, has acquired Akash, the physical IIT coaching company. PharmEasy, the online pharmacy, has acquired Thyrocare, a physical diagnostic company. Reliance Retail has acquired Just Dial, an online digital address provider. Online companies would like to buy out legacy physical companies increasingly so that the online business model is fortified. In certain cases, the physical companies which are digitally proactive may also acquire and integrate online specialist companies. Is Lenskart an online company or an offline company? It is a hybrid company. It has got facilities all across the countries like any other optical company, but they have a digital backbone. They have a centralized model of manufacturing lenses, frames, and assembling them and sending them all across India. Their physical costs are low, the stocking costs are low, and the digital backbone enables them to optimize on centralized manufacture and decentralized customer interface, in addition to the direct online interface. Strategic collaboration and operational synergy between physical providers, as in the case of food delivery companies, is also vital in the case of any other online-offline collaboration. The third one is transformation, that is connectivity as an industry. Connectivity has emerged as a new industry that not only spanned many existing industries, but also created new industry and market segments. Technology companies have created transformative industries based on digital technologies. This will be reinforced through higher level digital, such as artificial intelligence. It brought together advances in telecommunications, electronics, and software. Connectivity became a huge customer-centric technology-driven platform for a new wave of multiple industries and multiple businesses. As IoT develops further, every device will speak to every device. Every automobile will speak to every stationary and moving entity and the persons themselves. That's how the whole networking would take place. Information search, data analytics, social networking, and convergent communication have created new products and services and an entirely new domain of applications for products and services. Examples are from Microsoft, Cisco, Apple, Samsung, Google, Facebook, Amazon Web Services, Azure, and so on. Therefore, a new mega industry of conglomerate convergence has emerged, driven by these kinds of behemoths. It is important to note that these are creators of new products rather than providers of service. Models of structural analysis and industry definition need total reconstruction to cater to the reinvented mega industries of the networking era. Connectivity being such a dynamic and overarching concept, the traditional structural analysis does not seem adequate to define and quantify all the competitive. Transformation is best illustrated by the strides taken in the telecommunication field. The evolution of 5G over 4 decades from 1979 to 2019 is a striking example. In 1979, all we had was 1G, which is analog telecommunication methodology. With the advent of cellular telephony, text messaging came in a big way with 2G in 1991. 3G took root in 1998 with mobile and wireless internet connection. 2008 saw the introduction of 4G, cloud, IP, and truly mobile broadband. And launch of 5G occurred in 2019 with unlimited data capacity. 5G download speed is now faster than Wi-Fi for smartphone users in 7 leading 5G countries. If you see the 5G speeds, Wi-Fi is 59.8 download speed Mbps, 27.7 and 52.3 in terms of Wi-Fi download speed, 4G download speed and 5G download speed respectively. And in several countries, the speeds have gone up further, and the highest is in South Korea, Saudi Arabia, followed by Switzerland, Kuwait, Australia, Spain and UK. So there are no limits as to which type of country could have which type of download speed, because 5G can be universally deployed with unlimited data capacity with the appropriate infrastructure. And what do these terminologies mean? 1G, which is the first generation of wireless cellular technology, was launched in 1979 and it was used only for voice communication. It only delivered analog voice and there was no data transmission. 2G, second generation cellular network, was launched in Finland in 1991. These were digital networks, provided both voice and data communication services. With GPRS, 2G offered a theoretical maximum transfer speed of 40 kilobits per second. That's all. That really looks very small in today's. However, with the edge enhanced data rates for GSM evolution, we got a theoretical maximum transfer speed of 384 kbits. And today, many parts of the world are shutting down 2G services, but Indian population, especially in the rural areas, is still dependent on 2G. 3G, third generation cellular network, was introduced by NTT Docomo in Japan in 2001. Also, the term mobile broadband got introduced as it facilitated faster internet browsing. The 3G downlink data speeds were 384 kbits for WCDMA, 7.2 mbit per second for HSPA and 21.6 mbits for HSPA+. Then came the 4G. It relies on all internet protocol IP-based communication such as IP telephony instead of the traditional circuit switch telephony service. 4G got a footprint in HD TV stream multimedia, video conferencing, 3D television and gaming services. Data speeds 1000 mbits, peak upload 500 mbits. The world's first long-term evolution, LTE, branded as 4G service, was opened to public in Stockholm, Sweden and Oslo, Norway on 14 December 2009. However, it came to India only in 2012. 5G wireless technology is the latest in the generation of cellular networks. It enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects and devices without lag. Speed-wise, the 5G is faster than 4G. It can deliver up to 20 gigabits per second Gbps peak data rates and 100 plus megabits per second Mbps average data rates. As of July 3, 2019, mmWave had a top speed of 1.8 Gbps on AT&T's 5G network. Apart from just downloading a full-length HD movie in seconds, 5G is much significant than thought. It connects things virtually everywhere without lag. Thus, people can measure, understand, and manage things in real time. The global operators have started launching 5G networks newly in early 2019. As of now, 5G has been deployed in 35 plus countries. India is looking to deploy 5G in 2022, and the efforts are being made by the three telecom majors, Reliance Jio, Airtel and Vodafone Idea, to deploy 5G. This is the kind of transformation that has been happening technologically in the telecommunication field, and it is indicative of the industrial transformations that can occur based on great technological strides. Now let's look at the fourth frontier. It is the amalgamation of physical, digital and biological phenomena and attributes into new devices, equipment and in general new inventions. This is Industry 4.0 or the fourth industrial revolution. It is not inconceivable that in the future the world could be dominated by this new package of digital technologies and digital biological mechanical inventions. If you have an ambulatory sentry robot that has night vision, imaging, recording and replay capability, and if it has the ability to talk to residents and police in case of house breaks or suspicious movements, it can raise alarms, it can prevent all kinds of law disorder issues. It is a near-term possibility. Automation of coding and testing of codes as well as automation of routine software codes is also a reality. Self-programming through machine learning is in the works. Home and hospital bedside help by robots is also on the cards, spurred by the need to protect medical personnel from highly transmissible infections such as COVID-19. Labs on chips are now available. Cancer patients to tumor to sequencing to analysis and modeling and personalized therapy is also a goal that is within the reach. On the one hand, the Internet of Things would connect all devices and all people together. On the other, each industry or a set of industry would have artificial intelligence products enabling different ways of human living and other collaterals such as pet caring, crop tending, or animal protection. So the boundaries are erased. It is no longer a physical system, no longer a biological system, no longer a digital system. All will combine together. Neuroscience is taking great leaps with the implementation of chips and biosensor measurement. As of now, we already have Librate, which is a sugar measurement system on a continuous basis, which is connected to the computer. And as you take food, you can measure whether your sugar levels are spiking up and accordingly moderate the way you ingest food. So these are the kinds of changes that are happening under Reinvention umbrella. Autonomous electric car is an example of reinventing an industry in totality. From driver-steered internal combustion engine-driven car to autonomous electric or hydrogen fuel cell-driven car, which could also fly one day, is a great reinvention of the automobile industry. With digital technologies and sensor technologies achieving sharper levels of measuring, computing, and controlling, most products in basic industries are being reconfigured, reinvented to newer levels of perfection and innovation. While a car remains a car, it bears no similarity or resemblance in terms of functionality with reference to the previous generation of IC-driven cars. From fuel combustion to electric-driven, from human-driven to self-driven, and from accident protection to accident avoidance is a great leap that is happening in the new generation of cars. The future car with autonomous electric driving would therefore be entirely different. And if it starts flying, the limits are further enhanced. The structural factors that defined industry competition in Porter's model for the automobile industry are therefore no longer valid in their entirety because of the numerous new inputs, including but not limited to the engine systems, onboard computers, sensors, radars, lidars, cameras, software and artificial intelligence that would be part of the new generation of automobiles. These reinvented industries tend to have intense competitive pressures because of dynamic product evolution, because of the vendor power that is going to be exceptional, buyer diffidence as well as curiosity, national policies which will toggle between incentives and mandates, substitute products, because even before the ink has dried on electric vehicle designs, you are getting hydrogen fuel cell vehicle designs. So the change seems to be the only constant in these new industries. Models need to be specific to each reinvented industry. Force-fitting all the reinvented industries into standard structural analysis template obviously will not serve the purpose. So the structural determinants we all knew based on our previous discussions: entrants, suppliers, substitutes, buyers, rivalry. But if you look at the industry templates that we have discussed, whether these are applicable in toto or need to be changed is a matter of discussion. The basic framework of the 5 forces structural analysis, that is the force of entry, rivalry, substitutes, buyers and suppliers, remains valid. The economic forces which we have discussed in an earlier lecture, including the national government power, the national technological power, the collaborative power, the liquidity power, the inflation power, they also remain relevant. But the structural determinants vary significantly as a group when compared to the classic Porter delineation in classic established industries. But some industries will still be able to manage with the existing framework. Reinforcement and reconfiguration as industrial typologies will accept a standard template and will be well defined by this. However, transformation and reinvention will require new methods of structural analysis. Environmental changes, especially short-term ones, do not affect firms differently. They may not be relevant for structural analysis or industry definitions. However, changes in terms of emerging markets and technological openness are so transformational that they must be considered to be specifically impacting industries as well as the constituent firms. Now let us look at the threat of entry. The threat of new entrants to an industry is generally seen to be proportionate to the growth potential of the industry. In addition, the problems faced by the incumbents in terms of capacity and production shortfalls or quality issues provide positive market cues to competitors for taking advantage and providing market signals to newcomers for entry. Now, this threat of entry is moderated by the barriers to entry: economies of scale, product differentiation, capital requirements, switching costs, access to distribution channels, government policy. These are the 6 major sources of barriers to industry. When industrial change occurs, as I have described until now, these major changes are going to lead to major changes in industrial outsourcing. And that outsourcing occurs to emerging markets in certain cases, particularly the traditional industries. But the outsourcing is going to occur to the developed world in respect of the new generation industries. Therefore, there is a admixture of emerging nations as well as the developed nations participating in industrial restructuring that is happening now. Simultaneously, although the designs are finalized in the developed world, much of the design inputs are coming from the emerging world. Design and manufacturing is no longer a first world monopoly. It is a comparative advantage today of rapidly emerging markets such as China and India. Similarly, the wide development of internet and the power of 5G we have seen just now. This has altered the dynamics of switching costs and distribution channels. Reformist government policies have facilitated rather than prohibited globalization. Despite the protectionist voices and travel restrictions related to COVID-19, globalization as a phenomenon will remain. As an industry undergoes change, the threat of entry also undergoes a change. Apart from proprietary technology, one common advantage that a firm can have as an entry barrier across all new industries is control over new generation of electronics and digitization, and the power of corporate and product brands. The ability to collaborate creatively aids reconfiguration in industries. It transformed industries. This wave over the internet adds to control, while in reinvented industries, machine biology holds the key. Entry barriers based on age-old manufacturing technology paradigm have given way to ones based on a new range of communication, networking, automation, and intelligence technologies. In the past, the pioneer had experience on its side as an ethereal barrier. Today, the pioneer needs to be highly innovative to create entry barriers. Experience leads to better learning and thus better throughput and costing. But as industries are reshaped based on new technologies, including self-learning technologies, the pioneer has the advantage of forming the market first, but also runs the risk of differentiators gaining from the subsequent perfection of the pioneer's technology. Differentiators have been able to develop new overlays for the pioneer's technology to reduce the first incumbent's advantage. Therefore, electronics, telecommunication, and system software have the feature of multiple generations of technology leading to multiple experience curves. Proprietary development of multiple generations of technology is currently the only sustainable entry barrier. The only entry barrier to repeat is technology. Multiple generations of technology, as they get generated, place multiple entry barriers for entering into an industry. That is the truth of the day. Intensity of rivalry was essentially in terms of price competition, which operated independent of specifications. Customers perceived value by lower price, it being the function of the lower margins that a firm was able to afford. As per the conventional model, the intensity of rivalry is based on numerous or equally balanced competitors, slow industrial growth, high fixed or storage costs, lack of differentiation or switching costs, large capacity increments, drivers competitors, high strategic stakes, and high exit barriers. But today, price competition is much more sophisticated than just the price factor. It is in the terms of the range of products that a firm can operate at different specifications and price points with different levels of user experience. The rivalry has gone exponential. As the industry undergoes change, the intensity of rivalry also undergoes change. The parameters do not operate as in the classic Porter model. A shift in industrial action towards China and India and a native passion for high growth and intense competition determine the industry rivalry. The canvas for industry rivalry has shifted to emerging markets. Slow growth in developed markets because of economic deceleration has prompted in advanced countries to seek low-cost products and services from emerging markets. Generic pharmaceutical industry is a striking example of that. Several countries are mediated through multilateral agencies such as World Health Organization to receive products from technically capable emerging countries such as India and Russia, as well as China. Renault's Kwid small car, developed in India, is an example. At the same time, the opening and growth of emerging markets has prompted firms in advanced countries to seek a renewed and expanded presence in such markets for customer access. At the other end, the Indian pharmaceutical industry, through its aggressive development of generic medicines for the US market, ended up competing within itself. That is, too much of any good thing is bad. So as every country tried to enter the generics market of the US, the participants fought amongst themselves and lowered the industry attractiveness. So the intensity of rivalry among national and foreign firms for talent has also increased. That also leads to the intensity of rivalry undergoing an exponential change. The focus has shifted from formulating competitive strategy to realizing it through appropriate talent in the emerging market. So intensity of rivalry is proportionate to the intensity of change in technical and structural characteristics, which is also proportionate to the talent that is required to support the changes. These four new industrial typologies represent a new battleground for heightened rivalry in both advanced and emerging markets with interconnectivity of factor and customer inputs. Then there is pressure from substitute products. It is a competitive force even in normal industrial situation, and the pace of technological development dictates the potential for substitute products. All firms in an industry compete in a broad sense with industries producing substitute products. Sugar and sugar substitutes are competing products. Identifying substitute products is a matter of searching for other products that can perform the same function as the industry's product. The competitive force of substitute products has received rather perfunctory treatment compared to the competitive force of entry or rivalry in Porter's analysis. And this complexity of substitute products increases when the products are only partial substitutes of each other for certain product groups. In the contemporary world of technological convergence, the competitive force of substitute products is in fact the most intense. This works both ways in terms of unexpected substitutability as well as non-substitutability, challenging traditional structural analysis. With reference to the sugar example, the emerging trend is to move away from sugar substitutes as well and instead use other nutritious nuts and condiments that could provide near sweet impact with additional nutritional value. So there is a fundamental change in how industry mediated substitute products can be countered by other natural phenomena. As industry undergoes change, the pressure from substitute products also undergoes change. In the post-Fukushima tsunami world, nuclear energy has ceased to be a perfect substitute for other sources of power, at least in Japan and Germany. Renewable energy or solar energy development is seen as a viable and essential choice with improvements in technologies and adequate governmental incentives. The clean energy technologies would also decentralize generation and distribution of power to local communities. This will mark a fundamental change from the current models of power generation and distribution. The structural determinants for competitive force of substitute products must therefore now include government policies as well. On the other hand, certain other segments of new generation industries offer the paradox of product convergence and usage divergence. The continuous emergence of newer laptops, notebooks, netbooks, smartphones, tablets, and convertibles demonstrate how Connectivity is functionalized in multiple ways, even as all functionalities are integrated technologically. Product or service substitution needs to be a mega competitive force in any revised model of structural analysis that is focused on dramatically changing industrial landscape. For example, zero emission vehicles, clean energy, etc. Then we have the bargaining power of buyers. How is that changing in the new industrial configurations? Buyers compete with the industry by forcing down prices, bargaining for higher quality or more services, and playing competitors against one another, all at the expense of industry profitability. Buyer market conditions exacerbate the buyer power. If there is more supply than demand, buyers can choose and negotiate. Firms can lower price to sell. Buyers then have clear and high expectations of high quality and better service. And buyers also require superior technology. Therefore, firms are forced to invest in technology. Firms try to recover that through higher sales. There are other enablers as well, such as lack of brand loyalty, low switching costs, and commodity prices. Part of this enhanced buyer power is due to the choice offered by e-commerce in consumer-facing sectors and the power of e-auctions and e-bids in industrial commerce. Invisible competition exerts high buyer pressure. So the bargaining power of buyers also undergoes a change as industry undergoes change. Buyers or customers are the basic enablers for industry formation. As discussed in an earlier lecture, buyers should never be viewed as a competing force but rather considered as a collaborative force. Buyer power in today's world is scaled up by the firms themselves in an unending quest for market share. An unceasing wave of technological developments are now combining to prompt buyers to demand better features in their products or services. Market expansion and market segmentation are now inescapable in any industry to serve customers more perceptively. Segmentation should not be deployed to minimize the impact of buyer power. Latest technologies create products and services that shift customers from existing products and services and attract new or new customers to such products and services. Buyer power is thus linked to the need to be convinced of the shift. Clearly, buyer power is not a static concept. It is not a static competitive force in today's industrial scenario. Its dynamism is triggered by the rate of technological change and by the multiple ways in which the boundaries of technology are getting redrawn. As technological developments proceed apace without any let-up, these are combining to prompt buyers to demand better features. Firms need to recognize that as their products create new user segments, the balance of power is constant across buyer groups. The last but not the least, the bargaining power of suppliers. Like buyers are essential to create demand, suppliers are essential to create the products and services. Suppliers can exert bargaining power over participants in an industry by threatening to raise prices or reduce the quality of purchased goods and services. But these are self-defeating propositions. Porter's hypothesis on bargaining power of suppliers is rooted in classic industrial economics and does not recognize either the new platforms of supplier power or the collaborative nuances of contemporary supply chain management. Newer platforms of commodity and metal exchanges have emerged as instruments that drive product prices up or down in a global context. We have a gas exchange, we have energy exchange, we have rates, various other means of bringing together supplier power. Control over product prices no longer rests with the suppliers, given the shared interest and intent to benefit from market expansion that competitive products can help achieve. High scale does not necessarily mean that vendors can automatically dictate high prices. Multi-sourcing cannot be a means to reduce supplier power. It may in fact cause supplier instability and unevenness and diffusion of scale. Wise manufacturers now realize that their vendors also need scale, not merely to sustain themselves, but more importantly to reduce costs and enhance quality and even be capable of technologically advancing the current generation products. We have now complex interrelationships of owned and licensed patents and cross-supply of designs and components or assemblies. These are muting supplier power in the face of advantages of joint development of industries and markets. Suppliers who provide new generation inputs have significant power over industry behavior and firm performance. How is this changing as industry undergoes change? Let's see some examples. The new supply chain model in theory is insensitive to scale but sensitive to technology. Each industry under radical change, that is change other than ongoing reinforcement, needs to contend with the power of technology over supply capability. Automobile industry affected by semiconductors, sensors, electronics, batteries, radars, lidars and chargers. Renewable energy affected by critical commodities for solar, polysilicon, steel, aluminium, semiconductor chips, copper and other metals, as also solar modules and cells. Pharmaceutical industry is impacted by active pharmaceutical ingredients, intermediates, key raw materials, structural agents, catalysts. The model of the Japanese automakers working with their component and material manufacturers to optimize technologies is now more universal. Both end users and suppliers are now waking up to the advantages of strategic collaboration to ensure continued supply of low-cost, high-quality components and materials. So when you look at these changes, the 5 industry-level competitive forces and the 4 types of structural change can be plotted as follows. We have on the x-axis the 4 types of industry change: reinforcement, reconfiguration, transformation and reinvention. And vertically we have the 5 types of competitive forces: threat of entry, intensity of rivalry, pressure from substitute products, bargaining power of buyers and bargaining power of suppliers. When the industry change is of reinforcement, all these forces have high power. But when reconfiguration is taking place, they all slide down to low medium. And when transformation occurs, suppliers tend to have high medium power, buyers tend to have high medium power, as substitute products and rivalry would have. Threat of entry would be at medium power. But in the case of reinvention, existing suppliers do not have a bargaining power. Buyers would have a bargaining power because of their diffidence as well as curiosity. Pressure from substitute products would be low because the reinvented products themselves are the new substitute products. Intensity of rivalry would be low because this is a pioneering space, and threat of entry again would be low because these are the companies which are opening up a new industry. Reinforcement experiences the highest levels of competitive threats, while reinvention rides over competitive forces rather easily. The other 2 types of structural changes, which are reconfiguration and transformation, are affected in different ways as demonstrated. And all of these things are impacted by digital and technology. In general, the higher the level of uniqueness a firm achieves through digitization and proprietary technology, the lower the threat of competitive forces. Digitization reduces the level of competitive force. And more companies participating with digital technology will only increase rivalry but not change any of these pressures on the industry. So a holistic structural change, when it happens in the industry on the lines of reinforcement, reconfiguration, transformation or reinvention, will also require different kind of structural analysis. Porter's thesis of structural analysis, which is simple and focused on known industrial situation, has to be reconfigured to the industrial change situation of the current and the future, which is reinforcing the physical with digital, reconfiguring the existing businesses through digital, transforming the existing industry through new products and new digitally enabled products, and reinventing the entire industry itself. Therefore, structural analysis has to focus on single industry or multi-industry, multi-horizon, multi-industry network and digital plus situations. These must be customized to meet the needs of these 4 types of industry typologies. And there should be a more flexible definition of industry and a more perceptive identification of the competitive forces and sources of competitive advantage. And they must be developed essentially on technological dimensions, not in terms of the end providers of the force, be it the buyer, customer, substitute product or new entrant. What is driving all of these forces is the force of technology, which is leading to complete change of the industries. That is the lesson from this lecture. So thank you very much for your attention, and we'll meet again in the next lecture.